We are going to discuss three-layer hierarchical model in these visuals. We have discussed a lot of concepts. In our previous visuals, we have discussed different devices. These are the devices we use to build the network. Well, we have also discussed different topologies. We use these layer 3 and layer 2 devices to build the network, and we design them in a particular topology. This series belongs to CCNA, and under CCNA objectives we design networks of small to medium size. We design LAN and WAN under CCNA. We also implement policies through which our network works. These policies include routing, access control lists, network address translation, etc. We are going to discuss these policies in upcoming visuals. Well, the implementation of these policies is a part of CCNA. While building our network, we use these layer 3 and layer 2 devices and design them in a physical topology we have discussed under LAN and WAN topologies. Well, while building the network, apart from implementing the devices into physical topology, we also follow a logical hierarchy. Logical hierarchy means implementation of these devices according to their ability. To take care of all this process, we follow a three-layer model. Well, for building small network, this three-layer model is not followed completely. Usually this three-layer model apply on large networks. Even then, small networks follow this model partially. Well, this three-layer model is a logical hierarchy. There are three layers under this model which we follow for large networks. Now let's discuss these layers. Here you can see these layers: core layer, distribution layer, access layer. We are starting with core layer. Well, this is the top layer. This layer is considered as the backbone of the network. This layer deals with the high-speed data transfer. Usually connections like gigabit Ethernet are used for this layer. This layer is limited. Policies are not implemented under this layer because this layer deals with high speed data transfer. We comfort this layer by implementing this limited duty, and if we implement policies here, this implementation of policies will disturb the speed. We also care about this layer by implementing redundant links. Well, because this layer is a backbone, and failure of this layer will disturb the whole network. This is how we logically design core layer. Now Cisco 12,000 series switches, 7,000 series switches, 6,000 series switches. These are the Cisco heavyweights which are implemented under this layer for local area networks and wide area networks. Now let's move towards distribution layer. Now this is the middle layer. As you can see, we implement our policies here in this layer. We implement security, routing, quality of service. Well, the distribution layer follows these policies. This layer is between core layer and access layer. The layer below this distribution layer gets the access to the outside network through this layer, and outside network gets the access to the layer below this distribution layer through this distribution layer. Now the distribution layer allows or denies request here. The distribution layer follows the policies which we implement. As I mentioned earlier, policies like routing, filtering, quality of services, etc. This layer plays very important role for the network. Layer 3 routers are implemented under this layer. Now let's move towards final layer of this model. Now this layer also known as desktop layer. This is the third and last layer of three-layer model. Now this layer is placed at the end. The devices which play the role of access layer are placed at the end. Here end users connect to these devices, thus getting the access to the whole network. Well, layer 2 switches are implemented for this layer, and with this I am concluding this visuals. Well, we have discussed 3-layer hierarchical model. We discussed core layer, distribution layer, access layer. Now if you feel any problem regarding the concepts which we have discussed, you can just replay these visuals and be prepared for upcoming visuals. Thank you.